All right, for Algebra 2, we are doing solving systems graphically. 3.1 there. So solving systems is pretty much what most of this chapter, if not all of it, is about. Learning all the different ways that we can do that. So our objectives today are going to be to solve systems of linear equations by graphing, and then to classify a system of linear equations based on the number of its solutions. Okay, so first up, a system of equations is solving several equations. So we're going to have more than one equation, and they're both going to contain two or more variables. All of them are. Okay, that's a system of equations. The solution to a system is the set of points that make all the equations in the system true. So we're looking for all of those things. Graphing that we're doing today is one method to solve. Okay, we're going to learn several different ones. Graphing is one. It's the simplest, but it also limits. We can't use it for every equation. But in order to use graphing as a method to solve, we must find their intersection to find the solution. So their intersection is the solution. Okay, and we're going to graph using slope-intercept form, or you can use your intercepts. It does not matter to me in the least. So let's start with the first one. Solve the system graphically, which just means to graph it. In order to graph it, we need to get it in slope-intercept form. So I'm going to take this x plus 2y equals 4, subtract x. We're going to get it in slope-intercept form. So we have 2y equals negative x plus 4, divide by 2. Y equals negative 1/2 x plus 2. Because 4 divided by 2 is 2. So that's one equation. And we should go ahead and graph it. So my y-intercept is at, good, 2. So I'm going to go to 2, put my y. My slope is excellent, negative 1/2. So I'm going to go down 1 and right 2. Down 1 and right 2. Remember, I can also go up 1 and left 2. Up 1 and left 2. All right. Now in this case too, it is better to put more points than just the 3 because you're looking for the point of intersection. So I might have to end up going back and redoing that. I'm not for sure. Let's look at the next one. 2x minus y equals 3. So again, we're going to put it in slope-intercept form. So I'm going to subtract 2x. I have negative y equals negative 2x plus 3. Divide by negative 1. So y equals a positive 2x minus 3. Okay, so my y-intercept is where? Good, negative 3. 1, 2, 3. My slope is 2. So remember that's 2 over 1. So 1, 2, 1. 1, 2, 1. So right here, draw my line in there a little bit. Okay, but my solution to this problem is right here. There we go. It finally went. My solution is right there at 2, 1. Right? 2, positive 1. That is my solution. So I'm going to write solution 2, 1. That's it. And I had to graph it to find that point of intersection. All right, awesome. Then let's go on to the next one. Okay, again, you could use y-intercepts, the x and the y-intercepts if you want, where you plug in 0. That's okay. I'm going to stick with just the y or slope-intercept form for right now. We could talk about the other way in class if you want. Well, and we might do both on this one. We'll see. Okay, so with this one, let's start with our 2x plus y equals 0. We're going to get in slope-intercept form, so subtract 2x. Y equals negative 2x is my equation. So where's my y-intercept? Good, 0, 0, because it doesn't have one. My slope is negative 2. So I'm going to go down 2 and right 1. Down 2, right 1. Down 2, right 1. Down 2, right 1, up 2, left 1, up 2, left 1, up 2, left 1. All right, then, and I will connect those. I'm going to leave them, make sure my overlap is good this time. My other equation is 3x plus 2y equals 0. Oh, equals 2, pardon me. 3x plus 2y equals 2. So we're going to subtract 3x. We're going to get 2y equals negative 3x plus 2. Divide by 2. Y equals negative 3 over 2x plus 1. 2 divided by 2 is 1. So here's my equation for that one. All right, so my y-intercept is 1. So right here. My slope is negative 3 over 2, right? So I'm going to go down 3, 1, 2, 3, over 2, 1, 2. Oh, I just missed it. Down 3, 1, 2, 3, over 2, 1, 2. Looks like I'm kind of missing it. So I might go up. So up 3, 1, 2, 3, left 2, 1, 2. Bam. There it is. Up 3, 1, 2, 3, back 2. Okay, so if I connect these dots, right, this line, with my original line, okay, that's why I said, like, you might want to be a little bit more accurate and precise on some of your graphing here. My point of intersection was where? Good, it was the negative 2, 4. Oh, this time I got a gray one. So my solution, I meant to get red again, is negative 2, 4. It is that point of intersection where the two lines intersect. Okay. Now, what I was saying about you can also use your x and y intercepts, I'll show you with one of those. Okay, if you recall, to find the intercepts, you have to do it for each one. But you plug 0 in for x and solve, and then you plug 0 in for y. So in this one, I'd have 2 times 0 plus y equals 0. Well, 2 times 0 is 0, so that would leave me with y equals 0. I plugged in an x for 0, or 0 for x, so my coordinate is 0, 0 here for my line. And then I have to plug in 0 for y. So I'd have 2x plus, pardon me, 0 equals 0. Like this is the one I'm plugging 0 in for y. So then I would have 2x equals 0. This is not the best example. Divide by 2 on both sides. And x equals 0, 0. Okay. So in this case, it's really not helpful to use the intercepts because you don't. We got the same points here because their x and y intercept was 0, 0, which is what we see in that purple one, right? 0, 0 is where it intersects the x and the y axis. So graphing with the intercepts we can do, but sometimes we get stuck and we're like, how does that make a line? It's just a point. Well, then you have to plug in a different number if you choose to do that. Most of the time it works out well, but not always. Okay, let's clear this and go to the back. All right, on the back, we're going to talk about some types of systems. We have 3 different types, okay? And this is every system, how we can classify them. So, first up, our system is an independent consistent. Okay, we're going to write that one is IC, is how we describe it, or abbreviate it, I should say. It has a one solution, okay? It's one ordered pair solution. You're going to graph it and you're going to get one point of intersection. Now the cool thing about this, if we can do a slope-intercept comparison, the slope of the first equation is not equal to the slope of the second equation. Okay, you're like, duh, but some of them are like that. Okay, so these are just some characteristics here of the independent consistent systems. Then we have dependent consistent, which we would abbreviate DC. Their solutions, they have an infinite number of solutions. Okay, so you're going to notice that we have set notation and we have It's the set xy such that y equals, and we're going to have the equation of the line here. Okay, so in this case, y equals negative x plus 3. Okay, so that's a dependent consistent. And notice what happens because it has an infinite number of solutions. It's because one line sets right on top of the other line. Okay, so it sets right on top of the other line, which means if we compare their slope-intercept comparison, they have the same slope and they have the same y-intercept because they're the same line. They're the exact same line. And you're like, well, we would see that and notice that right away. That's not necessarily true because sometimes you're given an equation in slope-intercept form and then you're given an equation in standard form. And when you get them to the same, you're like, oh, like if you put them both in slope-intercept, then you'll see that there's the same line. But it's not always something you notice right away. All right, next up is inconsistent. Okay, so these we just say I usually. Inconsistent systems have no solution at all. No solution. So if we look at the graph, what do you notice about these lines that have no solution? Because, I'm going to put this here, because no point, PT, of intersection. Let me go. So there's no solution because there's no point of intersection. So what do you notice about these lines? Yeah, they're parallel. Okay, so when we compare their slope-intercept, they have the same slope because they're parallel, but they have a different y-intercept. Okay, when that happens, there is no solution because there's no number that will make all of or both of the lines, both of the equations true. Okay. All right, I'm going to move this on up. So I'm going to clear it and move up so we can start classifying each system. Oh, wait, hold on. We're not actually solving them. We're just kind of classifying them, but we do have to get them in the same form. So I just want to give you a little bit of, well, you have it on your sheet. You can reference it. Okay, so example 4. Sorry, we got the glitchy thing today. I fixed it for a while and then it's glitching again. I don't know what's going on. All right, so classify each system as independent consistent, dependent consistent, or inconsistent. All right, so the first thing we need to do is get these into the same format. Okay, slope-intercept form so we can see if they're going to have the same slope or different slopes. All right, so let's start with 3x minus y equals negative 1. We're going to subtract 3x. We would have negative y equals negative 3x minus 1. Divide by negative 1. Y equals negative 3 divided by negative 1 is a positive 3x. Negative 1 divided by negative 1 is a positive 1. Okay, so here's one equation. Now let's do the next one. 2x plus 3y equals negative 8. So we need to get it in slope-intercept. So we're going to subtract 2x. So we'd have 3y equals negative 2x minus 8. Divide by 3. So we would have y equals negative 2/3 x minus 8/3. It's kind of an ugly one. Okay, so one thing to ask yourself here is, what about my slopes? How do they compare? So my slope here is 3, negative 2/3 is my slope here. So yeah, my slopes are not equal. If my slopes are not equal, then my lines will intersect. And what kind of system is this? Right, when my slopes are not equal. Good, that is independent consistent, the IC. Okay, so that system is independent consistent. All right, let's try the next set. We've got 9x minus 3y equals 6, negative 6, and 6x minus 2y equals 4. So again, we've got to take our equation and put it in slope-intercept form. So I'm going to subtract 9x from both sides. I have negative 3y equals negative 9x minus 6. Divide by negative 3. And I'm going to have y equals negative 9 divided by negative 3 is a positive 3x. Negative 6 divided by negative 3 is going to be a positive 2. Okay. Our next equation, 6x minus 2y equals 4. So subtract 6x. We're left with negative 2y equals negative 6x plus 4. Divide by negative 2. Y equals negative 6 divided by negative 2 is a positive 3x. 4 divided by negative 2 is going to give us negative 2. Ooh. Okay, so again, let's ask ourselves, we need to look at our slopes between the two. My slope of 1 and my slope of the second equation. Well, the slope here is 3. The slope here is 3. So my slopes are equal. Okay, with that being the case, it can be consistent or dependent consistent, or it can be inconsistent. All right, so let's look at our b's. How about our y-intercept of these two? So here my y-intercept is a positive 2. In this equation, it's a negative 2. Well, that means my slopes are not equal, which makes this match up with this type. What is this type over here in that column? Good, it is inconsistent. So this one is inconsistent. All right, on to C. Let's get it in slope-intercept form. So we've got 3x plus 6y equals 9. Subtract 3x from both sides. We have 6y equals negative 3x plus 9. Divide by 6. So y equals negative 3 divided by 6 is going to reduce to negative 1/2 x plus, we could reduce these a little bit. 9/6 is equivalent to 3/2. Okay, so that's the first one. Let's do the next one. So we have 4y plus 2x equals 6. Subtract 2x. So we have 4y equals negative 2x plus 6. Need to divide by 4. So y equals negative 2 divided by 4 would reduce to negative 1/2 x. 6 divided by 4 can both be divided by 2. So we would reduce that to 3/2. What do we have there, right? Okay, so in this case, again, we're going to ask ourselves the same question. How about our slopes? Compare your slopes, first of all. Well, negative 1/2, negative 1/2. They're equal. Now we compare our y-intercepts. 3/2, 3/2. Oh, they're equal. Wait a minute, these are the same line, right? They looked very different when they gave them to us. But once we put them in slope-intercept form, created that level playing field where we could see all the parts, we recognize that they're the same line. So this time we're looking here where the slopes and the intercepts are the same, which make this a dependent consistent system. Okay. All right, that is it for today. Make sure that you keep your notes, because we're going to, next few classes, we're going to keep categorizing your systems or classifying them, okay, into what type of system to solve it and do it and classify the system. So we'll have more experience with that as well. All right, we'll see you guys tomorrow. Have a great day.